Hey guys, this is Mr. Lowry. I wanted to show you a quick geometric construction. So geometric constructions, recall, use our compass and our straight edge. So we've used these tools before. Sometimes they're a little tricky to use, but we use them to make angles and to bisect angles and to make perpendicular bisectors and things like that. One of Euclid's postulates says that we can use any point and then a segment to create a circle. So if we have a point, a center point, and then we can take a length, a segment length, and we can use that as a radius to create a circle. So real quick, I'm just going to do a circle for you. My hands are going to be in the way for just a minute, but I'll move them around. Now, when we did this in class, this could be a little tricky because your compass can move and things like that. And sometimes we don't have the best compasses to work with. But if we do it the right way, theoretically here, we get a circle. Okay? Now here's the point that I use, the center point. And the idea behind a circle, and this is something we talked about before the break, is that a circle is just a set of points. There's infinitely many points on this, circular line that I drew, the circumference that I drew. But the idea is that each one of these points is equidistant, or the same distance, from the center. Because these are all going to be radii of the same circle. So this distance is equal to this distance is equal to this distance. Okay, and we talked about that again before the break. We did it on the coordinate grid. So a circle, again, is just a set of points that are all equidistant from some center point. Okay, that's the circle. Now I want to do another construction with you. That's kind of the intro here. And instead of starting with just a single point, I want to start with a point and a line. And we're going to use these two guys as reference points to create a new shape. Okay? So what we want here, our goal here, is to try to create a shape where all the points on the shape are the same distance from this point as they are from this line. Okay? So to help me out with that, I'm going to create a perpendicular line that goes through this. And this is not part of our shape, this is just kind of a reference line. And if we were doing this, really rigorously, like Euclid, we would actually want to make a construction of a perpendicular line, which we could do. But just for the sake of time and for our purposes here, I think this will be sufficient. Okay? This is just kind of a guidance line. Now also what we're going to do is we're going to create a parallel line, a line that's parallel to this guy. And this is going to start to look a little complicated, but I think that the picture will come into focus here in just a minute. Okay? So remember, my goal is to create a shape where every point on that shape is the same distance from this point as it is from this line. Okay? So here's what I'm going to do. I'm going to come in and I'm going to measure this distance right here. I'm going to set my compass to that distance. So from this line to this point right here. Okay? And what I'm going to do is I'm going to set my compass on this point right here, and I'm just going to make a couple arcs that intersect that perpendicular line that I did. Okay? And I'll put a point here, and I'll put a point here. Okay, now what have I just done? Well, I measured the distance from this point to this line, and then I duplicated it right here, and I duplicated it right here. Okay? So what I know now is that this distance from this point to this line must be the same as the distance from this point to this line, because these two lines are parallel. So if I measure, perpendicularly, this distance would have to be the same as this distance right here, and that's the same over here. So because these two lines are parallel, all these three segments should be the same length. Okay? Now what I also did is I just made sure that this point is the same distance away from this point, so that this distance right here is also duplicated right here. So this point is the same distance from this point as it is from this line. And this point is the same distance from this point as it is from this line. Okay? So these are two important points. These are 2 points on our shape. Because again, the shape we're looking for is the shape where all the points are the same distance from this guy as they are from this guy, this line. Okay? So bear with me, we're going to do this a couple more times, and I think this will start to make a little bit more sense as we go. So what I'm going to do is just keep duplicating this process. I'm going to create another parallel line, okay, of a line that's parallel to this guy. And it doesn't really even matter where. It doesn't have to be a specific specific distance, we're just going to make sure that we copy that distance. So again, this is probably not perfectly parallel, but for our purposes, that's probably pretty good. Okay. So now what we're going to do is we're going to measure this distance right here. Again, the distance from the line that I started with to the new parallel line, the line that's parallel to that one. Okay. So I have this distance, and what I'm going to do again is I'm going to take my compass, I'm going to center it at this dot, and then I'm going to do a little mark here and a little mark here. And I'm going to put a point there and a point here. Okay, what do we know about these 2 points? Well, again, the distance from this point to this line is the same as this, right? Because these 2 lines are parallel. This line and this line are parallel. I made them to be parallel. So the distance from this line to this line has to be the distance from this point to this line, because they're parallel. And the same thing is over here. But I also copied that distance here, right? And here. So these 2 points are the same distance from this guy as they are from this guy. So if I kind of draw that in a little bit, this length here is the same as this length here. And this length here, whoops, should maybe do that a little bit straighter. This length here is the same as this length here, right? So again, this point is the same distance from this line as it is from this point. Okay? We're going to do this one more time, and then we're going to add another point down here, and we'll kind of see what the shape is going to be. So let's add another parallel line. Again, it doesn't have to be in a specific spot. We can do it a little closer, a little farther away. It doesn't really matter. Let's do it kind of close this time. We just want to make sure that whatever line we draw is parallel to this guy, or as parallel as we can make it here. Okay, so something like that. I'm going to grab my compass, and I'm going to set the point and the pencil here to the distance between those 2 parallel lines. Okay? Now I'm going to come over here, and again, I'm going to set my compass at this magic point here. That was our original reference point. And we're going to make an arc here. And we're going to make an arc here. And we're going to put 2 points there. Okay, what do we know about these points? All right, well, the distance from this point down to the line, if we measured it, perfectly perpendicularly, would have to be the same as the distance from this point to this point right here, because we constructed it to be that way. The distance between these 2 lines is the same here as it is here. They're parallel, so they're always going to be the same distance apart from each other. But we made sure that that distance was duplicated here, that distance from this center point here. That's this important landmark point. Okay? And that's true on the other side as well. This distance here from this, that's a little crooked, from this point down to this line is going to be the distance between these 2 lines. It's always going to be the same because they're parallel. But we also duplicated that distance here, and so this distance from this point down to this line is also right here. Okay? All right, there's one more point that we haven't added yet that's kind of obvious. So if we wanted a set of points that was equidistant from this point and this line, kind of the easiest point to get it would be just like a midpoint. So if I make a point that's halfway in between this point and this line, that would be maybe somewhere around here-ish. Now again, with a compass and a straight edge, we could create a midpoint, create a perpendicular bisector and get it perfect, but I'm just going to eyeball it. So this point would be the same distance from this point as it is from this line. And now we have 7 points, which is a pretty good approximation here. 7 points that are going to be part of our shape. So let's see if we can figure out what kind of shape that's going to make. It's a little crude here, but just to get kind of an idea. Does that shape look familiar? It should, because we've studied these quite a bit. This is actually what's called a parabola. Okay? So we've talked about parabolas before. They're the graph of quadratic functions, but this is kind of a more geometric view of a parabola. A parabola is a set of points that are all equidistant from some fixed point and some fixed line. And these two guys have an important name. This point right here, the point that we're kind of measuring from, our reference point, is called the focus. And this line that we're measuring from is called the directrix. Okay. So the definition of a parabola is a shape that's made up of a bunch of points that are equidistant from this focus and this directrix. So let's write this down. This is going to be the last part for this video. So a parabola is a shape whose points are equidistant. That's a geometry word that means equal distance, right? Equidistant or equidistant from a fixed point. And that point, that reference point that we're measuring from, is called the focus, and a fixed line. And again, that is called the directrix. So, kind of a quick construction of a parabola. And again, the important idea is that a parabola is a set of points that are equidistant from a focus point and a directrix, which is a line.